Hi, in this video I will define the melting point of an organic compound, briefly discuss the factors that determine the melting point of a compound, and then talk about the importance of melting point measurements in an organic chemistry lab. By definition, the melting point of a certain compound is the temperature at which the solid and the liquid phases of a pure substance coexist at 1 atmosphere. So whenever we have a solid, this solid upon heating will transform into a liquid. The temperature at which this transformation takes place is called the melting point of the compound, and it is usually measured under 1 atmospheric pressure. The melting point is one of the physical properties that characterize a certain compound, in addition to other physical properties such as the boiling point, the density, or the solubility. So a pure compound will always have the same melting point if it is measured under the same pressure. Now, we all know that some compounds have high melting points and others have low melting points. So what are the factors that affect or determine the melting point of a certain compound? The first and the most important factor is the strength of the intermolecular forces. We all know that the intermolecular forces are those forces which exist between the molecules of a certain compound. These forces are the ones which mainly affect and determine the physical properties of a compound. Now, as the strength of these intermolecular forces increases, the melting point of the compound will increase. And the reason is that we need higher energy in order to separate the molecules and move them from the solid state, where they are very close to each other, into the liquid state, where we have more space. So whenever the intermolecular forces gets stronger, this means that the melting point will be higher because we need more energy to separate these molecules. The second factor which also affects the melting point of a compound is the crystal structure. Compounds with crystal lattice structure have higher melting points, and the reason again is that higher energy is needed to break the highly organized structure. So compounds may either have a well-organized structure, such as, for example, this one which I'm doing here, and in this case, breaking this structure needs or requires high amount of energy, and that's why the melting point will be high. In other compounds, the structure may not be highly organized, for example, in this case here, and since it's not highly organized, this means that the amount of energy which is needed to separate those molecules will be lower. The atmospheric pressure also plays a role in determining the melting point of a compound. Increasing the atmospheric pressure will increase the melting point, and the reason is that the pressure will force, so the atmospheric pressure will force the molecules of a solid to stay together. It will prevent them from separating, and that's why the melting point will be higher. The other factor which may affect the melting point of a compound is the existence of some impurities. Impurities are usually known to reduce the melting point of a compound, and the reason is that the presence of these impurities will cause the intermolecular forces, will weaken the intermolecular forces which exist between the molecules, and that's why it will be easier to separate them. So, what is the importance of measuring the melting point of a certain compound in an organic chemistry lab? First of all, melting point measurements are used for compound identification. Pure substances have well-defined melting points with narrow range. So whenever you determine the melting point of a pure substance, you will notice that the melting point range, which is usually the temperature from which the first droplet of the solid appears until the whole solid is transformed into a liquid. This is called the melting point range. Usually pure substances will have a very narrow range, whereas if these compounds are contaminated with impurities, the range will be very high. So in order to identify a certain compound, let's say for example we have a compound, unknown compound, and we determined the melting point of this unknown to be, let's say, 120 degrees. Now we know we have a compound A, which is a known compound whose melting point is also 120 degrees, but we are not sure if this unknown is actually A. In order to identify the nature of this unknown and to confirm whether this unknown is actually A or not, usually what we do is that we mix the unknown with the suspected compound. So I mix my unknown with this suspected compound, which is A, and we check the melting point range. If the melting point range was very narrow, this means that the compound is actually pure, and this means that the unknown is actually A. Whereas if the melting point range was very high or very wide, this means that the compound A is actually different than the unknown. So compound A will be considered as an impurity. So this is how we determine or identify compounds using the melting point. Again, just to confirm this, that whenever you have a very narrow range, for example, in this case, we just have 3 degrees range, this means that the compound is pure. Whereas, let's say you were determining the melting point of an unknown B, and you notice that there is a wide range, this means that the compound is impure. Again, to confirm, what do we mean by range? So 97 degrees is the temperature when the first, let's say this was a solid, let's say when the first droplet of the solid changed into a liquid, the temperature was 97. And then it took the compound from 97 degrees to 122 degrees to completely transform into a liquid. This is what we call the range, or this is how we determine the range. So the range is the temperature from which the first droplet of the solid changes into a liquid until all the solid changes into a liquid. The second use for melting point measurements is to check the purity of a compound. So usually, as I said before, impurities reduce the melting point and increase the range of melting. So whenever we determine the melting point of a certain compound and we notice that there is a wide range, this means that our compound is impure and it should be purified. How do we measure melting points in an organic chemistry lab? We can do this in several ways. One of the most common ways is the one which you are seeing here right now. So usually we need a thermometer, and then we need a capillary tube. This is a capillary tube which is filled with our compound, and then the thermometer and the capillary tube are attached together and they are inserted in a beaker which contain an oil, usually glycerol, and of course we need a heating source. So we start heating and we look at this capillary tube. Once we notice that the first amount of solid changes into a liquid, we record the first temperature, which is T1. And then we keep looking at the solid until it is completely dissolved, and then we determine the temperature, and this is T2, and this is how we determine the range of melting of the compound. So the powder solid is placed in a capillary tube. It is attached to the thermometer. They are both immersed in an oil bath and they are heated. The temperature is recorded once the first droplet appears and until complete melting. There is also another way for determining melting points, which is using the melt temp, which is an apparatus for measuring the melting point. This is one form, this is another form, and there are several forms for this apparatus for measuring melting points. So to summarize, the melting point measurement is an important way to check the purity of a compound and or to determine the identity of an unknown compound in an organic chemistry lab.